In this lecture we will talk about DNS zone settings, different types of DNS records, and go over the most common ones. Let's go to the DNS Manager snap-in. Let's take a look at forward lookup zones first. A forward lookup zone allows the DNS server to resolve queries where the client sends a name to the DNS server to request the IP address of the requested host. When you install Active Directory domain services, a couple of forward lookup zones are created automatically. This MSDCS zone contains mostly SRV records necessary for locating services like Global Catalog or LDAP in your domain. For example, this record informs you that you can access LDAP on server 01 using port 389. We have already discussed LDAP in one of the previous lectures. SRV records specify a host and port for a specific service. In this case, it tells us that you can access LDAP on server 01 using TCP on port 389. Priority and wait values are used for load distribution. But I started with a rather complex type of record. I would suggest leaving this zone alone if you don't have any reason to go there and modify records. Let's instead focus on the second zone that was also automatically created. By default, you should have just a few records. Here is the A record for our server. You are most likely already familiar with the records that resolve DNS names to IP addresses. For IPv6 you would use Quad A records to do the same thing. Let's create a CNAME record. CNAME records are similar to a record. The difference is that they map a name to another name. If we wanted to use an alias for our server, this is how we would create. I will name it DC, short for Domain Controller. If you click on Browse, you can point it to an existing record. Another important type of a record is MX. MX records are used for mail exchange. If we had an email server, we would have to create a public MX record for it. You don't have to specify anything in the host or child domain field. If you leave it blank, by default all email for this domain will be routed to the mail server specified in the FQDN field. At the bottom you can specify priority for your server. If you had multiple servers, you can use this setting to specify which server is supposed to be queued first when email is getting delivered. The lesser the number, the higher the priority. Let's check the properties of this zone. On the General tab you can see the status of this zone. You can pause and start it. Let's look at the type settings. By default, this zone is created as primary and the information about it is stored in Active Directory. Zone information can also be stored in a file. You can create secondary zones, which are just replicas of a primary zone. When you do that, you have to specify the server where a copy of that zone will be obtained from. The third type is a stub zone, which is kind of a pointer that only contains NS, SOA, and possibly a records. A server containing a stub zone is not authoritative for that zone. The replication options let you specify how your zone is replicated. Since we only have one domain in our forest, the first two options make no difference to us. The third option is for Windows 2000 compatibility, which we fortunately do not have in our environment. Below this you can specify what updates you allow. When you select secure updates, only domain members are allowed to update their records. With non-secure updates, everyone is allowed to update their records. You can also prohibit any updates if you set it to none. The aging settings in conjunction with scavenging allow you to remove stale records automatically. Start of authority, SOA, record. This record is created at the beginning of a DNS zone file and specifies the authoritative name server for that DNS zone along with contact details for the domain administrator, domain serial number, and information on how frequently secondary DNS servers should query the master name server. Note the serial number field. If you have a secondary name server slave to this one, it will initiate a zone transfer every time the serial number increments. Name server or NS record indicates the authoritative DNS server for a given domain. In a typical scenario, after you purchase a public domain name from a registrar, you would set up NS records with that registrar to point to the DNS server that you will use for that domain. Internally, when you install the DNS role, this record is created by default and points to the internal Windows DNS server or servers. WINS is now an obsolete technology that has been replaced by DNS, and we will not discuss it. The Zone Transfers tab allows us to specify what servers, if any, we want to allow to transfer this zone to. If we had other DNS servers, we could specify them here. The last tab is Security. The main thing to know about it is that everyone has a read-only access and domain admins have full control. The default security settings work fine and I would not recommend changing them. There are many more record types you can choose from. For example, text. Text records are another type of resource records in DNS. These records are often used for identity verification. For example, you can use a text record to implement sender policy framework protocol designed to prevent spoofing. So far, we don't have any reverse lookup zones. A reverse lookup zone is an authoritative DNS zone that is used primarily to resolve IP addresses to network resource names. So, they perform the opposite task as forward lookup zones. Let's create a reverse lookup zone and I will show you how it works. This will be a primary zone stored in Active Directory. I am okay with this replication scope. This will be an IPv4 zone. Here you need to put the network portion of your subnet. I will allow only secure updates. So, we know the name of our workstation and can ping it. We get its IP. Pointer or PTR records allow us to create IP to name mapping. Let's do it for our workstation. Now we can use the nslookup command to find the hostname of an IP. Let's keep moving forward. Trust points are required for DNS security extension setup. This is a rather advanced topic and we will not cover it here. Conditional forwarders are DNS servers used to send queries for a specific domain. For example, if you had a partner organization that provided you with a list of DNS servers authoritative for their domain, you could add it here for faster DNS resolution. Instead of going to your ISP or Google DNS, this allows querying your partner's DNS servers directly, resulting in faster name resolution. This is all for this lecture. I encourage you to play around with creating different types of zones and records in your lab. If you have the resources, you can install another server and configure it as a DNS server. At my company we have multiple DNS servers all replicating DNS information. We have a few cases when one of the servers was down and we would not notice it for days because other servers kept working and it was seamless to end users. Please proceed to the next chapter where we will talk about DHCP.